So we're back after our break, and we're going to be looking now at aspects of the atmosphere that are fundamental to understanding the weather and climate. And a question we might ask is, how is heat transferred through the atmosphere? And the answer is three words that you should be familiar with. I put them in a homework assignment before the break, and you may have run into them in 7th grade. Conduction, convection, and radiation. Conduction is the transfer of heat by direct contact between atoms and molecules that have gained energy from the radiant heat that may have come from the sun or been released from parts of the earth. So when a molecule or an atom is energized and it collides with another atom or molecule and transfers heat by conduction. The air in the atmosphere conducts heat to and from the surface of the land and ocean because molecules of water come in contact with molecules of air, or molecules of rock and soil come in contact with molecules of water or air. Convection, however, is different because that's the transfer of heat in only a fluid due to a change in density of that fluid, so air or water. Hot, low-density fluids rise because as the matter within a given volume of air or water is heated, that volume expands. The expansion of that volume reduces the density of the volume if it remains the same. So we don't expand the volume. In fact, we keep it constant, but the molecules have moved apart and some have left that given volume. Therefore, we now have less matter in the same space and the density goes down and the fluid can rise. Air rising, warm air rising in the atmosphere. In our atmosphere, as air rises through the troposphere, as we now know, the temperature goes down and therefore molecules will increase in density as more are contained in a similar volume, and that air, cool now, will begin to sink, and that creates what's called a convection cell of rising and sinking. Warm air from the surface, cold air from the upper troposphere down. Radiation is the transfer of heat by means of electromagnetic waves through space, but also released from sources of radiant infrared radiation or heat. A simple diagram would have radiation coming from the ground and heating up molecules in the atmosphere on its way through the atmosphere and then down on the surface of the earth, water and solids. Then conduction would be the re-release of that heat radiating, but then not as a radiant source, but as atoms or molecules that have been energized by that original radiation or subsequent radiation and then come in contact, collisions. Conduction is through collisions or absorption from molecule to a molecule. Finally, then the convection, the example here given in the air of warm air rising at the surface, cooling, condensing, in this full case forming a cloud, and then air sinking back down. Examples of convection are the most important to understand in the Earth system. And so the first basic one that we're most familiar with in daily life is convection in a room. And convection in a room, as heat radiates into the air, causes the air to be heated, lowering its density. So convection in a room, as heat radiates into the air, heating the air and lowering its density. That's what we have here on the right. That's a terrible sentence. I don't know who wrote it. It may have been me. Here's the radiator, heat rising, the radiant heat, heating the molecules in the air over the radiator, spreading them apart, density goes down, air rises, and then the heated air rises, moves away from the source of the heat, the radiator, and sinks. And this is a convection cell. This is what we call it. And we see these in many parts of the earth. Here we see them surrounding the surface. Convection cells in the atmosphere rise and sink around the surface of the earth, causing winds as air moves from areas of high pressure to low. So here at the equator, air is rising from the surface. That's an area of low pressure because the air is lifting off the surface. Well, if this is an area of low pressure, then wind will blow towards it. And we see that that happens from both 30 south latitude and 30 north latitude, because at those 30 north and south latitudes, air is sinking. Higher density air in that same convection cell that started at the equator sinks at 30 north and south. As it sinks, it then spreads over the earth as wind. Here on the right is another form of convection that we often find at the ocean, where in the daytime, the land is heated more quickly than the water. This creates a local zone at the beach of low pressure that draws cool air in from over the water, and you get a cooling ocean or sea breeze, a breeze or wind off the ocean onto the land. At night, the pressure conditions flip because the ocean water will be warmer than the land, because land cools down more quickly. We'll learn about that very shortly. And so air rises, in this case, from the ocean up, sinking on the land, creating a cool breeze that blows offshore. These are convection cells in relation to wind. And here on the right, we see how convection in the upper mantle and asthenosphere of the Earth actually move the plates that cover the surface of the Earth. So convection cells are the cause of the motion of the plates that we call tectonic plates, and therefore the cause of earthquakes, volcanoes, the opening and closing of oceans over the course of time. And here on the left is just an example of how you could put two blocks of wood next to each other in a container of water, heat that water up and get a convection cell in the water, and that would move the blocks away from each other. An example of what is believed, what is understood to be occurring in the upper mantle and asthenosphere. And with that, I would like to just show you this funny little video, and we'll be done with this little section.
Hey kids, are you in elementary school like us?
No.
Do you love science? Well, we love science.
Take a deep breath. Get ready for one of the most hypnotic things you'll ever see in a science class. Have you heard that heat rises? Well, here you can see it's true for yourself. I've got some food coloring on the bottom of a plastic container, and there's a hot mug right underneath the red food coloring. As it's heated, the water rises. But I want you to look closely and notice something else. The blue on the sides is being drawn in. You can see it better when I speed it up. Here's the thing I want you to remember. When water moves from one place, it doesn't leave a void behind. Water from somewhere else has to move in to take its place.
Now this would be the same in the air. This video is using water as its example, but the same process in terms of warmer air rising being replaced by cooler air from the surface, being drawn in towards this red vertical area here. This would be what we would call the zone of low pressure, and air is moving in from a zone of higher pressure because the blue is sinking from high to low pressure, replacing the red and getting heated as it comes into this center of hotter air. So let's continue.
That's why you can see the blue food coloring coming in from the sides. You can see it better from above. Watch that blue food coloring get drawn in. Do you see it? The hot water reaches the top, and then it gets pushed toward the edges by more hot water rising from underneath it. As it goes out to the edges, it starts to get cool, and cool water sinks just as hot water rises.
And again, this is synonymous with air. Cool air sinks, hot air rises. The other thing we noticed in the image, just a little before it cut to the side of the top image, there's condensation on the plastic at the above because it's cooler at the top than the bottom, and so the water begins to condense. That is being vaporized by the heat applied to the middle cup.
If you watch really carefully, you can see it sink and get drawn back toward the middle. These are called convection currents, and you see them moving here in two big ovals. They're one of the major things that drive ocean currents, especially in the deep oceans. But it's not hot water rising that drives the ocean currents. It's really cold water sinking up near the poles. Here's a piece of ice that I froze with some blue food coloring in it, so you can see how cold water sinks. As water sinks at the North Pole, for example, water has to flow up from southern regions to take its place. And these currents travel around the globe, some of them taking 1,000 years to complete their course.
So again, to emphasize, we can see that this is absolutely analogous to what is happening in the atmosphere, but it also corresponds to what's happening in what I just described as the upper mantle and asthenosphere with magmatic fluid driving the motion of plates. So what we would have in this white would be, say, the land or ocean, continent or ocean basin, bottom of the ocean, which is solid, being moved to the left from the center and moved to the right from the center. Two plates separating as this plume of mantle comes up and drives them apart. And likewise, on the surface of the Earth, atmospheric air moving up when it's heated. In this case, the heat would be coming from above, from the sun, not from below, from a mug. But that air heated and drawn up with lower density, cooler air replacing it, called this motion over the surface is called the wind, and then the whole thing a convection cell. And I think actually that's enough of this, and I think that we can call this a completed video. So let's stop.